Okay, last section that we're going to cover in Chapter 3, 3.9 inverse trig functions. So we'll start with a little basic review of the inverse functions that we will be using. And unfortunately, this is supposed to be a review of trigonometry that you already actually know, but we will go through it and hopefully they'll ring some bells for you. Inverse sine. So the graph of y equals sine x on negative pi over 2 to pi over 2 is shown. On that interval from negative pi over 2 to pi over 2, y equals sine x is 1 to 1, and thus on that interval, the function has an inverse. Remember, things have an inverse if they're 1 to 1. So it turned out that sine, cosine, tangent, all of them, on their full domains are not 1 to 1. If you think about the sine curve graph, it keeps going up and down, up and down. It would not pass the horizontal line test, so it would not be 1 to 1. But if we restrict it to just this interval, it's 1 to 1, and so there will be a function. The function y equals sine inverse has a domain of negative 1 to 1 and a range of negative pi over 2, and then the graph is shown here. And that graph was just achieved by reflecting it across the line, reflecting the sine graph across the line y equal x. Now you don't, in there I have the two together. Not particularly important that you remember the graph, but here are some important details. The restricted domain of y equals sine x, we're going to do the restricted domain of negative pi over 2 to pi over 2, and then this range, like we know about the basic sine graph, it goes as low as negative 1, as high as 1, so its range was negative pi over 2. Then because we're talking inverses, the range of 1 is the domain of other, the domain of 1 is the range of other, and so the domain of sine inverse is negative 1 to 1, and its range, its output, is negative pi over 2 to pi over 2. So your input are just real numbers between negative 1 to 1, and your output, and you can think of them as angles if you want, your angles are between negative pi over 2 and pi over 2. Now what we really want to be able to do is just some basic inverse trig stuff. Note, this symbol is the notation for sine inverse, that is red, sine inverse. It is not equal to 1 over sine. The negative 1 is not an exponent. The negative 1 is the symbol that we use for sine inverse. And misinterpreting that symbol to mean 1 over sine is just totally wrong, and you will just lose all the points. You've got to remember that that is our symbol for an inverse function. So evaluate the following. So what we're doing this time is, each time, is we're asking ourselves this question: that this is going to equal the angle on negative pi over 2 to pi over 2, whose sine is 1/2. And so it comes really from just absolutely knowing those primary unit circle values. Can't emphasize enough that you know those primary unit circle values. And so the answer here that has the angle that has a sine of 1/2 is pi over 6. And it really is just memorization here. Same thing here. This will be the angle on negative pi over 2 to pi over 2, whose sine is negative square root of 3 over 2. Now here's the deal about the negative ones. The answer is just going to be negative. So once you decide, okay, the answer is going to be negative, now you can just ask yourself, where is sine square root of 3 over 2? That the negative values are just going to have the negative answers. And so then, since it's negative, the answer is going to be negative. Then I can just think about the positive, ask myself, where is sine square root of 3 over 2? And that is just pi over 3. And again, there's only going to ever be one answer because of what we restricted our range to. That we're only accepting answers between negative pi over 2 and pi over 2. So there's always just going to be one answer. And the same thing here. The angle on negative pi over 2 to pi over 2, whose sign is 1, and that would be pi over 2. And that's the sort of stuff we need for you to try to recall back from your trigonometric past. So there's a little brief introduction to inverse sine. Okay, moving on to inverse tangent. So there's my graph of tan inverse on negative pi over 2 to pi over 2. Notice an open interval, because at negative pi over 2 and pi over 2, tangent is undefined, so it's an open interval. On that interval, it's 1 to 1, so there does have to be an inverse. We can find the inverse graph by just flipping it across the line y equals x. And you can't even see that there. That's a horrible graph. I should do that better. It says shown below are the graphs of y equal tan x and tan inverse. You can't see the tan inverse, but the tan inverse is right there. You can just barely see it now. But again, we just get those graphs by doing the reflecting property. And you don't necessarily need to remember too much about the graphs. Otherwise, we go back to this good graph right here about, this is the good graph of tan inverse. And this is going to creep up in the future. The limit as x goes to infinity of tan inverse is pi over 2. That as we go off to the extreme right, my y coordinate is going to be close to pi over 2. And the limit as x goes to negative infinity of tan inverse is negative pi over 2. And I'm just going to throw that in now because that'll come up later in our futures, that the limit as x goes to infinity of tan inverse is pi over 2, and as x goes to negative infinity, the limit of tan inverse is negative pi over 2. And we can just see that graphically. And then if we put both the graphs together, tangent's the one that's going up and down, tan inverse the sideways one. But the graph's not terribly important here. Again, what's going to be important is knowing these guys down here, that we've restricted tangent to negative pi over 2 to pi over 2. The domain is negative infinity to infinity. So then when we start talking about inverses, because they're inverses, the domain of one becomes the range of other, the range of one becomes the domain of other. And again, the basic stuff we need for you to remember, or what I need for you to remember, is just doing some of these basic values again. And again, importantly, tan inverse written like that is the notation for inverse tangent. Tan inverse is not 1 over tangent. And anybody that tells me that, just major points taken away. These aren't even close to being the same thing. The negative 1 is not an exponent. The negative 1 is the symbol we use to denote inverse sine. Now, some of you may be used to the idea of arc sine, arc tangent. That's the same thing as inverse sine, inverse tangent. If you prefer the arc notation, that's fine. So doing these guys. So, a little harder. I don't know my tangent values as well as I should. So here's the honest to goodness way I'm going to think about these problems. Now, first of all, this is still going to be the angle on negative pi over 2 to pi over 2, whose tangent is square root of 3. And if you know that value just right off your head, well, then you just write it down. I frankly have to think about it this way. So the way I think about it, my thinking, tangent is sine over cosine. And let's put it this way. Let's put some thetas in there. Tangent theta is sine theta over cosine theta. And we're wanting that to be square root of 3, and to be really specific, square root of 3 over 1. So then I look at my fraction right here, and I think about this guy right here. And so what I want is I want the angle where sine involves square root of 3. Notice I didn't say equals square root of 3, because sine never equals square root of 3. Square root of 3 is 1.71 something. That's bigger than 1. But just matching up the numerator, I want the sign to involve square root of 3. And so we can note that sine of pi over 3, just like we did on the previous one, is square root of 3 over 2. And so tan inverse of square root of 3 is pi over 3. That I still really break it down to sine and cosine values because I know my sine and cosine values. So I break it up to sine over cosine. The sine's in the numerator, the square root of 3 is in the numerator, so I ask myself, what angle will involve an answer of square root of 3? And that's going to be pi over 3, and so pi over 3. Doing the same thing on the next one. This is the angle on negative pi over 2 to pi over 2, whose tangent is negative 1 over the square root of 3. So again, my thinking, and just like the inverse sine when we did before, the negative is going to be a negative answer. So you don't really have to worry too much about the negative. So tangent of theta is sine theta over cosine theta, 1 over the square root of 3. Because the negative is just going to have a negative answer. So again, matching things up. And so I want the angle whose cosine involves a square root of 3. And that'd be cosine of pi over 6 is square root of 3 over 2. So my answer, tangent inverse of negative 1 over square root of 3 is going to be negative pi over 6. The negative values is going to have the negative answers. And so that's the way I think of them. I still think of them in terms of sine and cosine. Now, if you had a great trigonometry teacher and they just pounded those values into you, well, then go with those values. So last one, angle on negative pi over 2 to pi over 2, whose tangent is negative 1. And again, the negative angles are just going to have negative answers, so I don't really need to worry too much about the negatives here. So let's just go tangent theta equals sine theta over cosine theta equals 1. Or that sine theta over cosine theta equals 1 over 1. Or that sine equal cosine. And so now I want to know where sine equals cosine. And that is pi over 4. And so tan inverse of negative 1 is negative pi over 4. And so I just break it down into sine and cosine because I know my sine and cosine values very well. But like I said, if you know your tangent values really well and you can just blurb out the answers, well then just state the answers. And that's the end of this first video.